Hi everyone, this is Kiranmai from H&S department. Today we are going to discuss about LED, a light emitting diode. So under this topic, we are going to have the introduction for LED, construction, working, biasing, characteristics, types of LEDs, and merits and demerits of an LED. First of all, what is an LED? LED is an optical semiconductor device that converts electrical energy into light energy. The basic concept of working is it converts electrical energy into light energy. So LEDs are the most widely used semiconductor diodes among all the different types of semiconductor diodes available today. LEDs emit their either visible light or invisible light when forward biased, which the LEDs which emits invisible infrared lights are used for remote controls. These are the some basic key points regarding an LED in day-to-day life and its working principle. Coming to the symbolic representation or a circuit symbol for an LED is just a PN junction diode with arrow marks facing outside, which states that the light is emitting out of the junction from a PN junction diode. Coming to the construction of an LED, this LED construction mainly consists of three layers deposited one on the other. First one is a substrate of N-type semiconductor on which a P-type semiconductor has been deposited. Between those N-type and P-type, an active region will be formed. These are the three layers by which semiconductor material can, by which an LED can be fabricated. Okay, and the active region is present in between the N-type to P-type semiconductor layers. In the figure, you can observe that this is a substrate on which an N-type material has been placed. Again, on the N-type material, P-type material is deposited. Then between those two N-type and P-type materials, a depletion region is formed, which is called as active region. An electrode has been taken out of the P-type material and another electrode is taken from the substrate. The electrode which has been taken from the P-type material is called as cathode, and the electrode which has been taken from the substrate is called as an anode. And you can see on the screen the very experimental construction for an LED, where you can observe that in the N-type region, electrons are the majority carriers which are present in the N-type region. Holes are the majority carriers in the P-type region. While joining them together, those electrons and holes move from one region to another region through the active region where their recombination happens and energy is emitted in the form of light. This is the constructional figure for an LED. Now coming to the working, so when you forward bias an LED, forward bias means just joining a P-type material to the positive terminal of the battery and negative terminal to the N-type of the N-type of a junction. Simply the PN junction is said to be in forward bias. Just LED has to be forward bias so that free electrons from N-type semiconductor and holes from P-type semiconductor are pushed towards the active region. Why? Because of the repulsiveness from the terminals of the battery. As p-type is connected to positive terminal, holes will move towards the junction, and the negative terminal is connected to n-type, and n-type electrons are moved towards the junction. When these free electrons, which are from the n side, and holes from the p side, recombine with opposite charge carriers in the active region, energy will be emitted in the form of radiations. Either it may be a visible light radiations or it may be an invisible light radiations. But in LEDs, most of the charge carriers recombine at the active region. Therefore, most of the light is emitted by the active region. Hence, the active region is also called as depletion region. Okay, so you can see on the screen the energy band diagram for an LED, where the electron from the conduction band is de-exciting to the valency band, where it will recombine with a hole and produces energy, emitted energy in the form of radiations. Either it may be a either it may be a visible light radiations or invisible light radiations. So biasing, coming to the biasing of LED, there are certain limitations for the biasing of any device. For the LED, it is in the range of 1 volt to 3 volt, where an LED can work very safely. differently, and the forward current ratings are from 200 milliamps to 100 milliamps. But if the voltage applied to the LED is in between 1 to 3 volts, it works very perfectly, because current flow for the applied voltage will be in the operating range. Whereas if the applied voltage is beyond this range of 3 volts, the depletion region of LED breaks down and electrical current suddenly increases, which thereby damages the device. So for operating any LED devices or LED components, we should be careful that the applied voltage should be in the range of 1 volt to 3 volt, so that it can be operated very safely. Coming to the protectiveness of the LED in a circuit, always an LED should be followed by an resistor, series resistor, which will like the which will be used for the uh, opposing high voltages and protecting the LED from any voltage fluctuations. To avoid this damage of LED due to high voltages, we are just placing a resistor in series with the LEDs, which is called a series resistor. This resistor restricts the extra current which may destroy the LED. Thus, this resistor, series resistor, is otherwise called as current limiting resistor, as it is limiting high currents to pass through the LED. Coming to the current produced, the current flowing through the LED can be given using Ohm's law. V is equal to IR, uh, as the voltage in the circuit will be equal to difference of source voltage to the voltage across the diode, that is Vs minus Vd is equal to If into Rs. Just to find out the forward current, just get resistance from left to right, you will get If is equal to Vs minus Vd by Rs, where Vs is the source voltage, Vd is the voltage drop across the LED, Rs is the current limiting resistance, and If is the forward current. So coming to the output characteristics of LED, which we can draw between two different characteristics. One is between input voltage and output current, and also output current and output light. We can draw two different characteristics for the LED. Here on the screen, you are having a characteristic figure between output current and output light. So as the amount of output light emitted by the LED is directly proportional to the amount of forward current, which means that if the current output starts in the if current output starts, then only light starts glowing in the circuit. So that's why output current is always directly proportional to output light intensity. So the graph will be a linear one between forward current to output light, where it will be a straight line passing from origin. Whereas when you draw a graph between input voltage and output current, it will be a non-linear curve, where up to certain input voltage there is no current in the circuit. After that, the current starts increasing in the circuit. So two different graphs. One is linear graph, that is in between forward current to output light, and a non-linear graph between input voltage to output current. So coming to the types of LEDs, there are two different types of LEDs. One is visible LED and the other one is invisible LED. Uh, Visible LEDs are the types of LED that emits visible light, which means that uh, it is completely like display illumination purpose or individually photo sensors. These are mainly used for this purpose only, where you can observe the light with your naked eye. Whereas in invisible LEDs that emits invisible light, which are mainly used for photo sensors and on remote controls and all. If suppose in your car parking area, you may use a remote control for operating your car where it is situated, like that, and in your TV operating remotes. And all those we are supposed to use invisible LEDs, whereas visible LEDs are most of the time like in series bulbs and all. So whatever the LED it may be, but it depends on the output depends upon the material what you had chosen for the fabrication of LED. So different materials has been used for the fabrication of LED, like gallium arsenide, which will emit red and infrared light, gallium nitride, which will emit bright blue light, yttrium aluminum garnet LEDs, which are used for the white light, like this gallium phosphide, red, yellow, green lights, aluminum gallium nitride, which will emit ultraviolet light, aluminum gallium phosphide, which will emit green lights. So, depending upon the material what you had chosen for the fabrication of LEDs, the output will be changed. So if you want to have a different wavelengths or different colors of light to be emitted out of an LED, we should choose a different forbidden gap or energy gap materials for the fabrication. Coming to the advantages of an LED or the merit of an LED, the brightness of LED can be varied very easily depending upon the current flow through the LED. If you want a very high intensified output, we should give a more input, and if you want a less intensified output, we should change its input to the lower values. So it can be easily controlled by a varying currents. So this makes possible to operate LED displays under different ambient lighting conditions. Okay, and the second application or the merit of an LED is it can consume very low energy, very cheap, readily available, light in weight, smaller in size, longer lifetime, very fast to operate, can be turned on and off very in less in time, and do not consist of any toxic material for the fabrication, and emits different colors of light. These are the certain applications or the figure of merit or the merits of an LED. So wherever you found that if you want to change the light very fast, if you want to operate a light which is of very fast reaction rate, then you should use an LED because it is having very fast operating rate. It can get turned on and off very less time. Then coming to the demerits of an LED, main demerits of an LED are it need more power to operate than a normal PN junction diode, and luminous efficiency of LED is little bit low. Luminous efficiency means it may get damaged very easily due to the energy fluctuations. And coming to the applications of LED, there are n number of applications which are present in nature, but few I had collected here, which will like the burglar alarm systems, calculators, picture phones, traffic signals, digital computers, multimeters, microprocessor, digital watches, automotive heat lamps, camera flashes, aviating lights. All these are certain examples what we had seen in our day-to-day life regarding an LED, which makes a prominent role in our daily life. Thank you.